Good evening, everyone. How are you doing, everyone? Can you hear me? Can you see me?
Yes, sir.
Voice is not good. किसकी आवाज थी ये? Ayush, Kaushiki, Vedaj, can you hear me?
Hello? Yeah.
Yes, sir.
Okay, so here we are once again into the physics class. And what was the discussion that we did in the last class? Anyone remembers it? What did we discuss in the last class?
What is a unit and why nothing is absolute and everything is relative?
What is a unit and why nothing is absolute, everything is relative. And we saw that. What are units, Vidansh? What is a unit? What do you mean by unit?
Sir, comparing standards.
Units are comparison standard. They are used to compare various physical quantities. By physical quantities, we mean something that can be measured, right? Okay. Now, let us. Okay. Let us compare. Let me where. Let us start today's class with this. What's happening? Okay, let us start today's class with this. We had understood what are units. Any physical quantity has two things, magnitude, and this magnitude has one number and one unit. We had seen that. Now let us also see that these physical quantities. I talked about some physical quantities which had magnitude. There were some physical quantities which had both magnitude and direction. Let us talk about them first. Physical quantities. So we can just have a look at them. Physical quantities now. At this stage, let us bifurcate them into two categories. We'll bifurcate them in a different way as well. Let us bifurcate them into two categories. One is known as vectors and the other one is known as scalars. Any idea about what is a vector quantity and what is a scalar quantity?
A vector quantity is magnitude with direction and a scalar quantity is just magnitude.
The quantities depend on both magnitude and direction.
Let us first try to understand. Let us first try to understand. Just a minute. Let us first try to understand what do you mean by scalars. Let us first understand what do you mean by scalars. Now, there are some quantities that can be described. There are some quantities that can be completely described. That can be completely described by their magnitudes only. We only need magnitudes. And with these magnitudes, we can completely describe these physical quantities. Now, it might be difficult for you to understand what do you mean by this term magnitudes only. Let us take some examples. For example, this physical quantity time. Now, if you talk about time, and if you say, for example, this class is for 45 minutes. Now, what is this 45 minutes? 45 minutes. This 45 minutes is basically the magnitude of time. Yes or no? This can be broken up into two parts. 45 is the number and this is the unit. So to describe this time, we only need the magnitude. When magnitude means we need a number and a unit, and we can simply describe these quantity by its magnitude. Now, can you think of some more quantities that can be described by simply their magnitudes? Let us count those quantities. Let me have some quantities which can be described by their magnitudes only. Tell me. Any quantity that you can think of?
Age, maybe?
Age. Age.
Yeah,
Age is a quantity that can be measured, but it is not treated as a physical quantity. Let us talk about length. Length of something. 5 meters, 10 meters. Yes, Vedant, you want to say anything?
mass.
Mass, 5 kg, 10 kg, 2 kg. 2 is the number, kg is the unit. Can you think of something else? Distance. Your voice is breaking better. Distance. Can you think of something
Volume.
else? Volume, yes. 1 meter cube, 2 meter cube. Volume. Density. Have you heard about this term? Density. All these are quantities that can be completely described. Speed. Have you heard about this term? Speed. We will come across this term speed very soon. Speed. These quantities are completely described by their magnitudes. You tell the magnitude and you completely describe them. Those quantities are known as scalar quantities. Now, what is the good thing about scalars? That important thing I hope you are all noting down. Important points about this scalar. Number one, it only has a magnitude. So let us write it pointwise. When you write something pointwise, it becomes easier for you to remember it. It only has magnitude. It only has magnitude. Number second, it can be added, subtracted, or multiplied just like numbers. It can be added or subtracted just like numbers. If you have a scalar quantity and you want to add them or subtract them, you can simply do it as numbers. For example, if I'm going from A to B and I'm following a path like this, and I say that from A to B, I have taken the distance traveled by me is, let us say, 5 meters. Now I continue my journey and I reach point C. And the distance I have traveled here is 6 meters. Now, if I ask you, what is the total distance traveled by this person or me? What would your answer be?
11 meter.
11 meters. And how did you get this answer? You simply added 5 meter with 6 meter. You forgot about the unit because unit was same. You added 5 with 6. You had 11. Then you put the unit 11 meters. If they would have been in different units, you would have to convert them to the same unit and then you add them. You know that, right? So similarly, if I have one mass 3 kg, other mass 2 kg, what will be the total mass when I put them together? 3 kg plus 2 kg, the answer would be 5 kg. Another example, if I say that I have taken 10 seconds to go from A to B and I have taken 5 seconds to go from B to C, what is the total time taken by me? What would be your answer?
15 seconds.
It would be simply 15 seconds. Do we understand this?
Yes, sir.
So,
Yes, sir.
how we have done this? We have simply added what? 10 with 5 or 5 with 6, whether it's meter or it's second or it's kg, doesn't make any difference. We have our answers, correct?
Yes.
Okay. So, these are quantities which can be described by their magnitudes only, and they can be added like numbers. These quantities are known as scalars. Now, what did you say are vector quantities? What are vector quantities? Vectors.
Sir, they are depend upon both of magnitude and direction.
So, these quantities require both. They require both what?
Um, direction and distance.
Magnitude and direction.
They require both magnitude and direction for their complete description. They require both magnitude and direction for their complete description, and there is something that I will add later on. Now, first of all, we have to understand the meaning. Why would some quantities need direction? Why? Why? Why there would be quantities that need direction? What would this direction tell me? I mean, what is the use of this direction? Velocity is 5 meter per second. Why direction? Acceleration is 5 meter per second square. Why direction? Force is 10 newtons. Why do we need direction? I'll just give you a simple example of trying to make some sense here. Why do we need direction? Suppose I have a body of mass m kept on a floor. Very simple thing. It could be a box, it could be anything. It could be a car, it could be a bus. Now what I'm going to do is I'm going to apply force on it at one point. You must know at which point I've applied the force, because if I apply force at different points, answer also becomes different. Now let us say if I apply force of 5 Newton like this, what might happen? I hope you know that the SI unit of force is Newton. Do we know this? Yes or no?
Yes.
Okay. So I apply a force of 5 Newton. Kaushiki, what do you think may happen here?
It's gonna move
It may probably move. In what direction it may move?
to the north. Oh,
It's not
east.
north. It's not north or east. I mean, in whatever direction I applied force, if I let me call directions like this instead of north, east, west, south. Let me call this as positive x. Let me call this as positive y. We understand this xy axis? Yes or no, everyone?
Yes, sir.
Yes.
Let me call the 4 directions like this. It is easier for me. So if I apply 5 Newton like this, what might happen here is the particle or this body may move along
Positive x.
positive x-axis. It looks logical. Okay. Now, if I just tell you, I've applied a force of 5 Newton on this body, I don't tell you the direction. I might tell you the point. I don't tell you direction. See what difference does it make. Now, the same force means same in magnitude, but opposite in direction. Same, but different direction. I applied in the upward direction. What do you think might happen now? What do you think might happen now?
It's gonna stay. Like
Might
it might
stay.
move up or
It might stay on ground or it might move up. सही है कि नहीं है आयुष और वेदांश? Correct or not?
Sir, it might move upward.
Or it might stay on ground. If उसका weight is बहुत ज़्यादा, it will not move upwards, right? Yes or no?
Yes, sir.
Same thing. I apply a force of 5 Newton backwards. What might happen now?
It moves towards negative.
It might move towards negative x-axis. It might remain at its own place. I apply 5 Newton force like this. Pull it downwards with 5 Newton force. Definitely, it's not going to move. It's probably going to change its shape, or something is. It might get pressed. It might get distorted. It might get deformed. As you can see, if I only just tell you the magnitude of this force, which is 5 Newton, and I don't tell you in what direction I've applied this force, in different direction, this force is going to do different things. Yes or no?
yes.
Yes,
Therefore, it makes sense. It makes sense with some physical quantities. If you want to completely describe them, we need to tell the direction also, because without direction, they do not make any sense. 5 Newton, just telling you 5 Newton applied on this block will not make any sense, because I've just given you 4 examples. There are infinite number of ways in which I can apply this force in infinite number of directions. And in every direction, it is going to have a different effect. And hence, with some physical quantities, you must say the direction together with the magnitude. Do we understand this? Can I have some reason that we understand this, sir? You understand this, all of you?
Yes, sir.
Okay. Now, let us look at another aspect of this one. So the first thing that we have understood about this vectors is that number one, they require both. They require both what? Important points. Number one,
Magnitude.
both magnitude and direction for their complete description. Now let us see if try to come back to the same scalar. First point, it only has magnitude, so I've written it has magnitude direction. The second point was talking something about how they can be added or subtracted. Now let us also talk about how they can be added or subtracted. Now see, let me take out these two forces from here. I've taken this out and I've taken this out. Oops, something else has been taken out. Okay. Now apply the red force on the right hand side, the blue or whatever color this is. I'm colorblind. I don't understand colors. I don't recognize them. And I apply 5 Newton on the other hand side. What is the net force acting on the body? If I call this force as F1, if I call this force as F1, if I call this force as F2. Now remember, whenever you have vector, we denote the vector by this sign of arrow, a ray. Do we understand the sign of vectors? This is how we define a vector. We'll come to it, how we define it. This sign tells us that this is a vector. So this is F1 vector and F2 vector. If I ask you what is the net force acting on the body, what will you say? What is the net force acting on the body? You will say that the net force acting on the body, which is again a vector, is the sum of these two forces. It's always the sum of these two forces. In this case, one force is backwards, the other force is forward. The net force becomes 0. Yes or no?
Yes.
Yes, sir.
Now, what I'm going to do is, I'm going to cancel this force from here, and I'm going to apply it in this direction. Again, 5 Newton, and I now call this force as F2. Now, if I talk about this case now, and if I say what is the net force acting on the body here, it is still equal to vectorly. We'll still write it as F1 plus F2. Do we understand this? It is still the addition of two forces. But now what is your answer?
10 Newton.
But now your answer is 10 Newton. Now I ask you this, why is the answer in both cases different? In both cases I've added the forces, but in both cases the answers come out to be different. Why is it different? Why is one answer 0 and the other answer 10?
Because the direction is different.
Because direction matters. Yes or no? Direction matters. Direction matters a lot. In fact, if I apply 1/4 F1, which is 5 Newton like this, and 1/4 F2, which is 5 Newton like this, the answer in this case, the addition of these two forces will go like this. That will be the net force in this case. And that will be in magnitude, it will be √2 multiplied by 5. Why is the addition of the two forces giving me different answers in different cases? It is because of the direction of these forces. And hence, these forces cannot be added just like numbers. I cannot say how much will be 5 plus 5 in vectors. Because 5 Newton together with 5 Newton can be anywhere between 0, which is the answer when both are opposite, to 10 Newton, which is the answer when they are in the same direction. So 5 plus 5 in vectors can be anywhere, anything between 0 to 10. It depends on what? Depending on
Direction.
their directions. And hence, they cannot be added like numbers. They cannot be subtracted like numbers. They are added and subtracted using some special laws. And these laws are known as vector law, and follows vector laws of addition. We have to add this red line because they cannot be added or subtracted just like numbers. They need special ways. There are special methods to add vectors, and those special methods are known as vectors laws of addition. We have to add this line. Then you will ask, sir, why there is a need to add this line? Even if you don't add this line, you can just add it here in important points. You can just add an important point number 2. Important point number 2. They follow what, Koshiki?
Vector laws of addition.
They follow vectors law of addition. Just write this and be happy. Why you have to add this into the definition? We have to add this into the definition because of one particular quantity. Is one particular quantity which is an exception. And that is why the line in red is very important. There is one particular quantity which is a big exception to the definition, and because of this particular quantity, we have to add the red line. It must follow vector line because all quantities which have magnitude and direction, you will now assume that every quantity which has a magnitude and direction will behave in this way. If it goes here, the sum of this and this will depend on direction. But there is one quantity whose sum does not depend on direction. Let us suppose there is a wire carrying current I1. It comes at a point, then it bifurcates. I1 and I2 are coming in, I3, I4, and I5 are going out. Now current, do you know about current? Current has both magnitude and current definitely has a direction. As you can see, I have drawn I1 is the value of current and direction I have shown. All these currents are meeting at point A. Are they following vector law of addition for meeting at this point? They do not follow vector law of addition. So simply what I say, and you will do this probably in your next class or maybe in 12th standard, that you will find that this I1 plus I2, which is the incoming current, will be equal to I3 plus I4 plus I5, which is the outgoing current. Incoming current is equal to outgoing current. Current is a quantity which has both magnitude and direction, but it does not follow what?
Vector laws of addition.
It does not follow vectors laws of addition. And hence it is not treated as a vector. So remember this. Current is one particular quantity which has both magnitude and direction, but it is not treated as a vector because it does not follow vector laws of addition. Am I clear with this?
Yes.
That
Yes,
is
sir.
why for this particular quantity, we have to add what? We have to add this red line in the entire definition, and this red line states that any quantity which has magnitude and direction and also follows vector laws will be treated as a vector. If it does not follow vector law, it will not be treated as a vector. The example is current. Am I clear? Can I have some raise hand that we understand this? Can you just tell me? There are only 3 people. Have you understood this? All of you?
Yes.
Yes, sir.
Okay. So that was the definition of vector quantities. What are these vector laws of addition? Probably I will not tell you now, maybe later on when you get older and wiser. Maybe I'll tell you about these quantities, but I'll tell you something about vectors because I find it fascinating, and most of the kids, even in 11th standard, are scared of vectors, and I don't want you to be scared of something which is very good. Vectors. No. Every vector has a magnitude, it has a direction. So let me draw something which has a magnitude and a direction. Let us say this is A, B. So basically, if you look at A, B, and you look at it from a math perspective, you will say AB is a ray. Yes or no? AB is a
Yes, sir.
ray. Yes, it is a ray. It starts from point A and it goes to point B. This point A is known as the tail, the point where it starts, tail of the vector, and this point is known as the head of the vector. Tail, head. Do you understand this? Tail, head. And how do we write this vector? I write this vector as AB and I put this tail to head. So this now represents the vector AB. A is the tail, B is the head. Do you understand this?
Yes.
Now this vector should have two things. It should have a magnitude, it should have a direction. Now when you talk about the magnitude of the vector is the length of this line. And the length of this line is simply AB. Do we understand this? So the magnitude of this vector is the length of the line AB, straight line AB, not a different line, straight line AB. And you can write this length of the straight line AB as AB vector, and you put two vertical lines. These two vertical lines in maths, when you become wiser, you will understand that these two vertical lines in maths means magnitude. Do you understand the magnitude of the vector AB?
Yeah. Doesn't it mean the
Yes.
value is positive?
Yes, because it is length of something better. It is the length of the line joining A with B. So length cannot be negative. That is why I put the absolute value sign. You might know it as absolute value. You can call it as magnitude. Clear?
Yes.
Let us talk about its direction. How is the direction given? Now you can just simply think it of as the direction of this vector is from A to B, or you can say from tail to head. Do we understand this? Tail to head, A to B. We got this?
Yes, sir.
Okay. Now, since we have seen this, we can also see some different types of vectors. Number one is null vector or zero vector. What will be null vector or zero vector? Null vector or zero vector. It is a vector with zero magnitude. And undefined direction. What type of thing can have zero magnitude? A point or a dot. I make a point or a dot. This point or a dot is known as null vector. Do we understand this? It does not have any magnitude. Its direction cannot be found out. If it is a point, you don't know where this point is pointing to. We don't know its direction and the magnitude is zero. Such vector is known as null vector or zero vector. Do we understand this?
Yes.
Yes.
Is it difficult to
Yes, sir.
remember?
No.
Okay. First vector is null vector. I hope you are writing. Second, parallel vectors. What will be parallel vectors? Physics is simple. To understand the meaning of term, you will be able to find out what that term means. Parallel vectors. What will be a parallel vector?
Two vectors that are the same length. I mean,
That
they will
have
meet, never meet.
Yeah, that
Same
has same
direction.
or parallel direction. They have same or parallel direction. What about magnitudes? They can have
Any length.
any length. So same or different lengths or magnitudes. Because we are not talking about magnitudes here, we are only talking about their direction. So they have the same or parallel direction, but they can have any magnitude. Magnitude can be same, magnitude can be different. Am I clear?
Yes, sir.
Number
Yes,
3,
sir.
equal vectors. What would be equal vectors? Think about it.
Magnitude and direction are equal.
Yes, same magnitude plus same direction. Or you can say they are parallel vectors with same magnitude. Do we understand this? They are parallel vectors with same magnitude. Do we understand this?
Yes, sir.
Yes.
Opposite vectors. What would be opposite vectors?
Opposite direction.
Yes, simple. Vectors with opposite directions. What about magnitude? Magnitudes can be same or magnitudes can be different. Do we understand this?
Yes, sir.
Magnitudes can be same or magnitudes can be different. Okay. Negative vector. What do you mean by negative vector then? Same magnitude and opposite direction. Do we understand this?
Yes.
Or you can say opposite vectors with same magnitudes. For example, if I have AB vector, what will be the negative of AB vector? Let us say this is my AB vector. This is my AB vector. What will be the negative of AB vector? Negative of AB vector would be?
BA vector.
Yes. So negative of AB vector would be equal to BA vector. Do we understand this, everyone?
Yes, sir.
Yes, sir.
Simple. Anyone having any doubt up till here?
No.
No, sir.
How many we have done? 5. 6. Unit vectors. Now what would be unit vectors? Vectors with magnitude of 1 unit and a definite direction. These unit vectors are denoted by the letter hat. Hat. For example, see, an example will make you understand things. I have this vector which is my AB vector. Okay. What I do here is I draw a vector in the same direction as AB And if the magnitude of this vector is 1 unit, this vector becomes AB hat. That means it becomes a unit vector in the direction of AB vector. Are you getting my point? For example, AB vector is force, and this is a force of 5 Newton. AB vector is a force, and this force is 5 Newton. Then AB hat will also be a force. The magnitude of that force will be 1 Newton. Do we understand this?
Yes, sir.
So AB is a vector. Let us say the magnitude is 5 Newtons. It will have a magnitude, it will have a direction. AB hat will also have the same direction, but the magnitude will be 1 Newton only. Are we getting this point?
Yes, sir.
Yes, sir.
Now, how do I get the value of this AB hat or AB cap? We are doing what we are supposed to do in 11th standard. It will be AB vector divided by the magnitude of AB vector. This is how you get AB hat. You can write it like this. AB vector divided by the length of the side AB will give me AB hat. Do we understand this, beta?
Yes, sir.
Yes,
Any problems with this one up till now?
No, sir.
Okay. The last in this category and the most important one of these is number 7, which is known as position vector. Number 7, which is known as position vector. Now, what is this position vector? Anyone, any idea? What is this position vector? What I'll do is, we'll discuss about this position vector in details in the next class. Okay. Till then, I'll give you a homework, and the homework would be find out. You have internet, you have everything. Find out what do you mean by this position vector. Get the details of this position vector. Search on the net. Find out from somewhere what do you mean by this position vector, and put your answers in your group. You have that group now, WhatsApp wala group.
Yes, sir.
You can put your answers there. Tell me, what do you think about this position vector? Because this position vector is going to serve a lot of purpose in what we are going to do in the next coming classes. Now, as I told you beforehand, beta, that what we are doing here is not a part of your curriculum of 9th standard anywhere. Why we are doing it? Because we are supposed to be learning some new things, some new terms, velocities, displacement, acceleration. To have an understanding of those terms, because those terms are going to be vectors as well as scalars, you need to have understanding of these vectors. And most of these terms, the first term that will confuse you is displacement. And to understand displacement, you have to understand this position vector. So I'll give you time. Find out what do you think is position vector. Search it on the net and tell me in the next class. Before the next class, you can put it in the group. Find out about these position vectors and let me know what you think about them. I'll probably take your next class on Saturday. If not Saturday, probably Monday. Okay. I'll get a schedule. I'll get my schedule as well done. So I'll take your next class. Till then, if you have any doubts, you can always put it there in the group and I will discuss this. What's happening in your school, by the way, anyone? Before winding up the class, let me wind up the class first and ask you about what is happening in your school. So let me wind your class